right, we're going to do another one here where we're going to actually construct, all right, a one sample, all right, t interval for means. Okay, so without further ado, that's going to be number 2, and we're going to use our calculator for that. But to help us out, we're going to also use this for number 1, which we're going to actually find an n value. So let's read this one. Administrator of your school wants to estimate how much time students spend on homework on average during a typical week. They want to estimate the mean at a 90% confidence level with a margin error of 30 minutes. Okay, so we have a confidence level of 90%. We have a margin of error, which is going to be 30 minutes. Okay. And the pilot study indicates that the standard deviation of time spent on homework per week is about 154 minutes. So we know that we have a standard deviation of 154. So this indicated, so this is our pilot. So this is our observed standard deviation from our experiment. So how many students need to be surveyed to meet the administrator's goal? Now, like if you've done the other ones when we had a p interval for proportions, in order to figure this out, we need to find an n value. So how many students do we need to survey to meet the administrator's goal? Okay, so we're looking for an n value. Well, the n value, if you recall, comes from, we have our mean, all right, our point estimation, plus and minus, all right, our critical value t, because this is for means, times our standard error, all right, times standard error. And that standard error together is going to equal our margin of error. Now, the equation for the standard error, as we all know, standard error is equal to, all right, the standard deviation of our experiment divided by the square root of n. Okay, so what we're going to do is we know we want our margin of error to be 30, all right, 30 minutes. And we know we have, okay, right here, we're looking for an n value. So in this case, because we do not have a t-square and we don't know what this n value is, we're not going to use a t. We're actually going to change this and we're going to use a z, all right, a z-score, because we do not know what n is, so we can't figure out a degree of freedom for this, and so we're just going to use z, okay, and we are given a standard deviation as well. So in any case, we're going to go and find a z-score for 90, okay? So if you go, all right, to your calculators, you can do some inverse norm action here, or if you remember from your other experiments. All right, so we have this right here. Okay, and we have this and this and that and the thing. All right, we should have a critical value of 1.64, 1.64. And now we're going to find our standard error. So now we're going to say this, and this is going to be multiplied, all right, by 154 divided by the square root of n. Now we're going to do some algebra. Help us figure this out. So from here, what we can do is we can multiply and divide. So if we take n is actually going to equal, all right, 1.64 times 154, all right, divided by 30, and then we're going to square this, okay, square this. So if you did this algebra to solve for n, cross multiply, divide through, square it, and so our final answer, our n value that we're looking for, you put in your calculator, you do all this wonderful things, all right, and we have 30 minutes, square it, and we should have about 70.87, all right, so approximately 70.87, but obviously you can't have that many pairs, so we're going to round it up, and so we have an n value of 71, all right, 71 students, 71 students. All right, so 71 students, that's what we're looking for here. Beautiful, awesome. All right, so using margin of error, just like we did before, because we didn't know the t value, usually was means, we're going to change that to a z value because the t value, all right, n value unknown. All right, use z for your critical value. All right, so let's go down here. All right, we're going to take a little time, and now let's do this, and now let's figure out how to find a confidence interval for means here. So we're going to have a biologist studying the healing of skin wounds, measured the rate at which new cells closed a cut made in the skin of an uneuthanized newt. All right, nice newt. Here's the data from a random sample of 18. All right, random sample of 18 newts measured in micrometers, millionths of a meter per hour. Okay, so each one of these is a value for the measurement of per hour of the newts. So we're going to calculate and interpret a 95% confidence interval for means healing rate of P. So here we go. The first one is we're going to state what we're looking for. Well, what are we looking for? Well, we're looking for this. And what is that? That is the true mean healing rate. All right. At a 95% confidence level. And that's what we want to do. We want to state what our actual parameter is. So remember, we want to state the parameter. All right. And the level that we're using. All right. That's what we want to state. And we would state that right there. Okay. The second part is we want to do our plan. What are we planning on doing? Well, we're going to use, I don't know, how about a one sample, all right, t interval for means. That's what we're looking for here for the mean. And that's what we're going to do here because we do have one sample, all right, one sample of 18 newts, and we're looking for a t interval because we're talking about means here. We're going to be using t. But now we have to check out our conditions, okay? So what is our conditions? Well, the conditions to make sure we can do this, first off, is it random? Well, yes, it is. It's a random sample of, we got 18 newts. So that's cool. All right. Second thing, is it independent, my friends? Is it independent? Well, you know what? 10% condition says it is because 18 newts is probably less than 10% of all newts. All right. If you think about that, that seems pretty obvious. And the third thing is this normal? All right. Is this normal? All right. Well, right here, since our n value, and we're talking about means, okay, it doesn't say this is normal, okay, it doesn't say this is normal, all right? And so what we want to do is, and since we can't use, and the n value is not greater than or equal to 30, so central limit theorem does not take effect, so we can't use that. So what we're going to do is we're going to do a quick little graph of this information, all right? And we're going to see what this information tells us. So right here, we're going to take our number of newts, and if you want to quickly graph this, what we're looking for is there any outliers or anything like that to behold? All right, so if we go right here, let's just say from, all right, we'll go from this from 0 to any values from 0 to 15. Okay, and then we'll go 15 to, we'll go for here, and we'll just go by 15. So, all right, 30, and then 30 to 45. All right, 45. Probably that's maybe a little too big, but I will go with it. All right, so if we just enter those in there, so how many was our count? And for this right here, I'm just going to make a histogram of these values. And so what we have right there is going from 15 to 30. So 1, 2, all right, 3, 4, 4, 4, 4. All right, so 1, 2, 3, 3, 4, 4, 4, 4, 5, 5, 5, 5, 5, 5, 5, 5, 5, 6, 7, 7. All right, 7, 8, 9. All right, so we have 9 of these values right here. Okay, so we'll go 3, 6, and 9. And we'll just draw this right here. This could be a 9 value. Whoop. All right, 9 values there. All right, number of newts. All right. All right. This is actually per hour. All right. meters. Okay. All right, this is the number of newts. Number of newts. Okay. All right, and this is my per hour, micrometer per hour. And then we'll go from 0 to 15, 0 to 15. All right, we got that one, we got that one, 1, 2, 3. It appears we have 3 right there. Boom. All right. And then we go for the last one. All right, 30 to 45. So 1, 2, 3, 4, 5, and 6. And we have 6 right there. Well, looking at this, actually it looks pretty symmetric. So there appears to be, all right, no strong skews. All right, and outliers. So we're going to assume, all right, assume approximately normal. All right, so that's what we're going to assume. Okay, so we're going to assume that's approximately normal when we graph that out. All right, now from here, all right, we're going to do the do phase. All right, so from our do phase, what we want to do is we need to know what is the, out of this data, all right, that we have right here, we need to know what is the mean, and then we need to calculate, all right, our critical value, and then we need to know what our standard deviation of this is, and then our n value, okay? That's how we're going to figure this out. Now, to do this, we're going to use our calculators, all right? So if you take out your calculator, okay, we're going to actually do this right here, and we're going to go to Stat, and we go to Edit. In our list one, we're going to list all of these values, all those values. Once you get that, you can second quit, and you're going to go to Stat, and we're going to go to Calculate. We're going to go to a one variable stat, because this is what it is, one variable, all right, one sample. And we're going to go one sample stat, and we're going to go to list one. We don't have any frequency charts or anything like that, so we're just going to calculate, and it's going to tell us, all right, what's our mean? Well, from here, we see our mean is going to be 25.67, all right? So 25.67, 25.67, plus and minus, we'll find our critical value in just 1 second. We're going to find our standard deviation right here. Standard deviation, this is our standard deviation of the sample, 8.32. So put in 8.32. Divide by the square root of n, and our n in this case is going to be 18. All right, 18. We find our t value. Okay, we're going to find our t value right here. Well, what we know is that we are looking for a 95% confidence interval, and we have a degrees of freedom of 17, because remember that degrees of freedom is always n minus 1, n minus 1. All right, so we have 18 minus 1 will be degrees of freedom of 17. So we're going to go over here, and we can go back to our calculator if we want to. You can get inverse t. All right, and we're going to go 1 minus 0.95 divided by 2, and we'll have degrees of freedom of 17. So if you take out your calculators, you can go and go second vars, and you see this little 4 right here, inverse t. I'll press 4. All right, our area is going to be, I'll put in parentheses right there. All right, what is that going to equal? If you go through and figure all this out, all right, what is our area? Well, all right, 0.025. All right, so 0.025, and our degrees of freedom are 17. We'll figure what that t-value is, and that t-value is going to equal, whoop, all right, 2.11. 2.11. We'll go 2.11. 2.11, and that is our critical value. You could also go to our calculator, or actually go over here, okay? And if you go down here, all right, we have degrees of freedom of 17. We are looking at 95%, all right, which you see is going to be our 2.025. And looking at that right there, you can see that, oh yeah, there it is, 2.110. All right, 2.110. And going down there, is that what we got? There you have it, 2.11. Beautiful. All right, so both cases, you see that we have our same value. So going from here, plug in all of our values to find our critical point. So we have 25.67 plus and minus 2.11 times 8.32 divided by the square root of 15. And then you can go through and calculate what our margin of error is. And you can do this, hopefully you're doing it on your own, or maybe you're fast forwarding some of this stuff. All right, I got a margin of error of, all right, 4.1, we'll go 4. So they're rounded to 2 decimal places anyway. We'll go 4 right here. And that is going to be 25.67. And so we'll continue our little thing. We'll add 25.67 plus 4.14. So our top end is 29.81. And then our bottom end is going to be 21.53. And that is our confidence interval, my friends. That is our confidence interval. So the final thing is, what did we just find here? What is our conclusion? Yeah, this takes some time, but after you do a little bit, it gets a little faster. So what did we conclude? Well, we are 95% confident that the true mean, all right, what are we looking for? True mean healing rate. True mean healing rate. Rate of newts. All right. Is on the interval 21.53 to 29.81. And if we want to put in that thing, millimeters of micrometers per hour. All right, micrometers per hour. Micrometers per hour. All right, and that's what we concluded. Awesome sauce. All right, so what did we just do here? Well, we found what n is, all right, using what we know about t intervals and margin of error. We then went through the 4-step process of stating what the parameter was and also the level. We went through and stating what we wanted to find, a plan of one sample t interval for a mean by using all the conditions, random, independent, and then graphing out this to see, make sure that we didn't have any strong outliers or skews. Because we couldn't use the central limit theorem and we didn't know if it's normal. We then went through and calculated this by finding our t-value, critical value, using our standard deviation, finding our mean, using the data in our calculator to help us figure that out. That was the key thing. And then finally concluding, we are 95% confident the true mean healing rate of newts is on the interval 21.53, 29.84 micrometers per hour. And I hope this helps you out in finding your other confidence intervals and makes you a little bit more confident when you're doing your AP stats homework. All right. Good luck and God bless.